video is for Levi and Landon. This is the Chapter 4 Geometry Test Review. Landon, if you finish that quiz review and don't have anything else to do, please work on this so you can be caught up when you come back. That would be awesome. And Levi, I hope you brought your book home so that you can work on this before you get back from fall break. So here we go. Problem 1 is from page 151, 1 through 4 and 6. So 1 is a picture of a right triangle with all sides unequal, so that's a right scalene. Question 2 is 2 sides equal, so that's an acute isosceles. 3 is all sides equal, so that's acute equilateral. 4 is one angle bigger than 90, so that's an obtuse scalene. And 6, a right isosceles would have the two legs equal and the hypotenuse different. Question 2 is to write out the corollaries to the triangle angle sum. So the first is the acute angles of a right triangle are complementary. The second is each angle in an equiangular triangle measures 60, which is 180 over 3 or 60. Now page 3 is page 172, problem 11, and it says find measure x, z, y, the lower right hand angle, if measure WYV equals 130 and measure ZXY equals 24 as shown. So since measure of WYV equals 130, WXYZ equals 130 by vertical angles, and measure XZY is 180 minus 130 minus 24 because all the angles in a triangle add to 180, and so that's equal to 26 in the lower right hand corner. Now find measure W or Y, YWV if measure WYX as shown equals 48 and measure YVW as shown equals 25. Well, this is the exterior angle theorem now, and 48 equals 25 plus the angle that we're trying to find, the upper left-hand corner. So measure YWV equals 48 minus 25 equals 23. Now question 4 is really easy. It says if triangle QMN is congruent to triangle LPS, name all the corresponding parts. Well, angle Q is congruent to angle L, the first. Angle M is congruent to angle P, the second letter. And angle N is congruent to angle S, the third letter. And segment QM is congruent to segment LP, segment MN is congruent to segment PS, and segment QN is congruent to segment LS. Now for 5, we say name each property of congruent triangle or triangle congruence. Triangle ABC is congruent to triangle ABC, which is reflexive. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to ABC, just reversing the order. That's called symmetric property. And if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to GHI, then the first triangle ABC is congruent to the third triangle GHI, which is transitive, which we've done a lot with. Now question 6 is from page 180, numbers 3, 4, and 5. On number 3, we're asked to say what will it take to make an SSS congruence for these 3. So we have triangle QPR and STR with 2 parasides congruent. So in order to get a SSS, we'd need segment QR congruent to segment TR. Then we could have triangle QPR congruent to triangle STR by SSS. And for 4, segment AB is congruent to segment AC because of the converse of the isosceles triangle theorem, because angle A and angle C are congruent, the opposite sides are congruent. And AD is already given as congruent to CD, and BD is congruent to itself, so ABD is congruent to CBD by side, side, side. I didn't need to add anything. And for 5, angles P and R are congruent, so PQ and QR are congruent. And vertical angle PRQ and TRS are congruent, but also angle R and T are congruent, so RS and TS are congruent, and R is given as the midpoint of PT. So all three sides are congruent, therefore we can say triangle PQR is congruent to triangle TSR by side, side, side. Now 7 is from the last section, 4.6, which is the right triangle congruence formulas or congruence properties. So for problem 8, we have triangle ABD congruent to triangle CBD by the leg BD and the angle A and C congruent, with angles ADB and CDB being right angles, so the right angle congruence LA congruence applies. Now for 9, we have PR congruent to SR, which is hypotenuse, and we have the vertical angle PRQ congruent to SRT. So we have triangle PQR congruent to STR by hypotenuse angle congruence, because angles Q and T are right angles, therefore I can use the right triangle congruence. And for 10, we have angles D and angles F being right angles, and DE is congruent to EF, and EG is congruent to itself. EG is the hypotenuse, and DE and EF are legs. So we have, by right triangle congruence, triangle DEG is congruent to triangle FEG by hypotenuse leg congruence. Now problem 8 comes from problem page 171, example 2. Given that A is congruent to D and angle ABC is congruent to DCB, prove AC is congruent to DB. Well, angle A is congruent to D and angle ABC is congruent to DCB given. Segment BC is congruent to itself, reflexive, and therefore I have two angles and a side. So triangle ABC is congruent to triangle DCB by AAS congruence, and I can get my AC congruent to DB by corresponding parts of congruent triangles are congruent. Now page 181, number 7 is part A. List all the triangle congruences for non-right triangle, and that's side, side, side congruence, side, angle, side congruence, angle, side, angle congruence, and angle, angle, side congruence. And then page 188, number 1 through 4, for the right triangle congruences, leg, leg congruence corresponds to side, angle, side congruence. Hypotenuse angle congruence corresponds to angle, angle, side congruence. Hypotenuse leg congruence corresponds to side, side, angle congruence, which doesn't exist, so that's none. And leg angle congruence corresponds to angle, side, angle congruence. Problem 10 is taken from page 201, number 14, where my exterior angle, 132, is supplementary to angle 1, and angle 1 and 2 are congruent because they're opposite the sides that are congruent. So angle 1 and angle 2 are the same and are 180 minus 132 or 48. And angle 3 is supplementary to angle 2, which is 180 minus 48, which is 132 again. Now angle 4 and angle 5 are congruent because the opposite sides are congruent, and I can find that by 180 minus the 132 angle 3 cut in half for the 4 and the 5. So that's 48 over 2 or 24 for angle 4 and angle 5. Now angle 6 is equal to 180 minus the 248s, 1 and 2. So that's 180 minus 96 or 84. And angle 7 is equal to angle 4 plus angle 1, which is 24 plus 48, which is 72. Now, problem 11 comes from page 152, numbers 14 and 16. And problem 14 says we need to add up the interior angles of the triangle. So x plus 2x is 180, or 5x is equal to 180, divided by 5x is 36. So angle S, the x, is 36, angle T, 2x, is 72, and the external angle SRQ is supplementary to 72, which is 180 minus 72, or 108. Now problem 16 has the internal angles x, x minus 20, and x minus 40, which are added up and equal to 180. And doing the algebra, we have 3x minus 60 equals 180. Adding 60, we have 3x equals 240, or x equals 80. So the measure of angle V is 80, which is x. X minus 20, the measure of angle T, is 60. The measure of angle U is x minus 40, or 40. And the external angle SVU, which is supplementary to x, is 180 minus 80, or 100. Now question 12 is finding the exterior angle x with two remote interior angles, which is equal to x minus 60 plus x minus 20. So doing the algebra, we have x equals 2x minus 80. Subtracting 2x, we have negative x equals negative 80, or x equals 80. And therefore, we have measure of L, which is x minus 60, which is 20 degrees, and the measure of angle M, which is x minus 20, or 60 degrees, and the measure of LNM, which is the remaining angle inside the triangle, which is 180 minus 80, the x, or 100. Now 13 is to, first of all, look at triangles AGC and DEB. So AB and CD are listed as congruent, angles A and D are congruent, and angles G and E are congruent. So first of all, AB plus BC is equal to CD plus BC, so I can say that AC is congruent to BD by the addition property of equality, adding BC to both sides. And therefore, triangle AGC is congruent to triangle DEB by angle side congruence. So then I want to find the measure of angle BFC, the top angle of triangle BFC, if measure of BCF is 50 minus 2x, and measure of CBF is 4x minus 10. Now, since they're in a congruent triangles, and they're angles opposite congruent sides, I can set the angles equal. So 4x minus 10 is 50 minus 2x, and adding 2x to both sides, it gets 6x minus 10 is 50. Adding the 10 to both sides, I get 6x is 60 and x is 10. So measure of BCF, which is equal to the two bottom angles, is 50 minus 2x, or 2 times 10, which is 30, which is also a measure of CBF, and therefore what's left of the triangle is 180 minus the 230s, or 120 degrees for my answer. Problem 14 and 15 have to do with the mid-segment theorem, which is 4-7, which we didn't cover due to time constraints so that we could finish the test last Friday. But what this says is that if D, E, and F are midpoints of their segments, then segment AB and DF formed by the midpoints are parallel, and DF is 1/2 AB. And AC works for all three of them. AC is parallel to DE, and DE is 1/2 the length of AC. And BC is parallel to EF, and EF is 1/2 the length of BC. Now we're going to use for 14 and 15, AB is parallel to DF, DF is 1/2 AB, and AC is parallel to DE. So first we get the distance for AB. So AB, using the formula square root of x2 minus x1 squared plus y2 minus y1 squared, is, we'll take B first, as 1 minus a negative 4 squared plus 4 minus a negative 8 squared, which gives us 5 squared plus 12 squared, which is 25 plus 144, which is the square root of 169, or 13. Now DF from our mid-segment theorem is just 1/2 of AB, or 1/2 of 13, which is 6.5, so that's easy. Now D is the midpoint between B and C, and the midpoint formula, which we've done before, is x1 plus x2 over 2, y1 plus y2 over 2. So that's 1 plus 8 over 2 and 4 plus 1 over 2 are 9/2 and 5/2. Now for 15 to find the slope, m sub AC, we're going to take C first. So 1 minus a negative 8 for y's over 8 minus a negative 4 for the x's is 9 over 12, and if I divide both by 3, I get 3/4. Now from our mid-segment theorem, DE is parallel to AC, so the slopes are the same, which is 3/4. And since AB is parallel to DF, angle A is congruent to angle DFC, which is 23 by corresponding angle postulate. Now 16 uses the mid-segment theorem to explain why triangle KML must be a right triangle. So given that K is the midpoint of LJ and M is the midpoint of LN, we have KM parallel to JN by the mid-segment theorem, and given that MN is perpendicular to JN, so that MN is perpendicular to KM by the perpendicular transversal theorem, therefore angle KML is a right angle, so triangle KML must be a right triangle. And for 17, we have the triangles FGE and HGE with FG congruent to HG, FE congruent to HE, and FH parallel to GE as our givens. So for step 2, angle FGE and angle HGE are right angles, definition of perpendicular. Step 3, FGE is congruent to HGE, all right angles are congruent. Angle F is congruent to angle H, isosceles triangle theorem. Angle FEG is congruent to angle HEG, with two corresponding angles congruent implies the third angle is congruent. GE is congruent to itself by reflexive, therefore FGE is congruent to HGE by definition of congruent triangles. This is giving all three angles and all three sides being congruent. On 18, we want to prove that G is the midpoint of BE, where we're given that angle 1 is congruent to angle 2 is a given, and G is the midpoint of CF. So FG is congruent to CG by definition of midpoint. Angle FGE is congruent to angle CGB by the vertical angle theorem as shown. And therefore that gives us enough to have triangle GFE congruent to triangle GCB by the two angles and the side, angle-angle side congruence. And therefore BG is congruent to EG by corresponding parts of congruent triangles are congruent. And that allows us to say that G is the midpoint of BE by definition of midpoint. Now 19 is to write a flowchart proof showing that triangle WVX is congruent to WVZ. Well, we start with angle VXY is congruent to VZY as a given because that's shown. And then we can say that the opposite sides, XY is congruent to ZY by the converse of the isosceles triangle theorem. And when we say WX is congruent to WZ, which is given, and WV is congruent to, WY is congruent to itself reflexive, those all feed into triangle WXY is congruent to WZV, the big triangles by side, side, side. And then because of that congruence, we have angle XWV congruent to angle ZWV by corresponding parts of congruent triangles are congruent. And with WX still being congruent to WZ and WV being congruent to itself for reflexive, we can now say the triangle WVX is congruent to WVZ by side angle side congruence. And then our last one is to use the figure to write a paragraph proof proving the exterior angle theorem, where 1 is my exterior angle and 2, 3, and 4 are my interior angles to the triangle. So since angle 1 and angle 2 form a linear pair, measure of angle 1 plus measure of angle 2 equals 180, but measure 2 plus measure 3 plus measure 4 equals 180 by the triangle angle sum. Therefore, measure 1 plus measure 2 equals measure 2 plus measure 3 plus measure 4. Both sides equal 180, so therefore transitive works. And therefore measure 1 equals measure 3 plus measure 4, subtracting measure 2 from both sides, which we call the addition property of equality. So now Levi and Landon, work on these if you can, and do your best to get these done by a week from Monday. And have a good fall break. This shouldn't take you very long.